And it's over to you, Mr. Martineau.
Good morning, everybody, or good afternoon, wherever you're at. Going to carry on from where we were yesterday. Do a quick little recap. We're discussing alignment angles, both what is adjustable, what's non-adjustable. I hope you guys are seeing me now. Is that true, or can somebody give me some feedback?
Yes, we're seeing you for sure.
Okay, so I've got the whole screen.
That's right.
Okay, so we're going to switch over to our presentation and do a quick little recap of what we discussed yesterday. So, we didn't spend a lot of time talking about camber. We got more into talking about steering axis inclination, in talking about included angle, scrub radius, those types of things. So what the plan today is we're going to carry on and start talking into caster and the effects there. But just yesterday, like I said, we did talk about scrub radius, and really scrub radius, when we get into it, is the pivot point for the tire. And the tire is going to pivot around that point. And we said that an SLA with positive scrub radius will have a natural tendency to toe out because it's pivoting on that inside portion of the tire, and the dynamic action when you're going down the road is that this will want to toe out. So we always set these with a little bit of toe in so that hopefully when we're going down the road, the wheels are running straight ahead. We talked about strut type suspensions and where they tend to run a negative scrub radius. And the negative scrub radius now is that the natural tendency for this tire is to toe in. One of the prime reasons we said that happens.
Rick, real quick, we lost your full screen. You're only like a little sliver corner.
Oh, really? Okay, what happened there? I'm going to go back to sharing.
Yeah, you're only on 1/4 of the display.
How about now?
Yes, yes, you're back.
Okay.
Much better, much better.
Apologize for that. So negative scrub radius is the tendency for the tire to toe in. One of the reasons we did this was as we went into diagonal split braking systems, because we had the front wheels doing so much of the work, that this actually tended to have the tire pull into the vehicle if we got into a system failure. Let's say we lost half of our brakes. Now the tire would want to push into the vehicle, giving us more control rather than on the old system where we have positive scrub. The natural tendency for a tire would be to pivot out and cause a pull. So that was one of the big reasons for going to the negative scrub. We talked about included angle. Included angle is the combination of the SAI, the caster put together, and that would give us our included angle. We talked about included angle being, oops, too far. On a SLA, the included angle is really controlled by the spindle. The spindle will move when we move the upper control arm as the typical place to adjust this. But what we're changing in that case is SAI and camber. The included angle is built into the spindle. And when we measure our included angle, we can determine as a diagnostic if the spindle is bent or not. When we go back into the strut, there are two places to adjust. We can adjust at the top of the strut. Moving the top of the strut in and out also changes SAI and camber, but the included angle stays the same, just like the spindle. And if the included angle is off, we could have a problem with a bent strut or something like that. But there are systems out there where we adjust the front camber at the middle point, or where the knuckle meets the strut. And in that case, we're actually changing the included angle and having less effect on SAI. So we always have to be cautious of that. And there are some reasons why manufacturers don't build any adjustment in there, is that they don't want you changing the included angle. They want you to figure out what's wrong and fix it. Okay. So today we're going to move forward and get into talking about caster. And caster, again, is an angle where we tilt the steering axis, but in this case, we're tilting it forward or rearward. So if we tilt the top of the steering axis rearward, it's going to project the load slightly in front of the tire and get the tire to follow the load. That is referred to as positive caster. If we tilt the axis the other direction, now where the tire is leading the load, that is referred to as negative caster. So in both cases, we're moving from left to right on the screen. Again, lots of exaggeration in these, but it helps to do the explanation. So we go with positive and negative caster. In the case of using our trainer, we have again added an adjustment to the top of it where you can actually change the caster on this vehicle that normally did not have a caster adjustment. So there's a set of knobs mounted at the top of that plate, and you can actually see the arrow up on top here where we can actually go in and adjust the caster. Looking at this is that we talked yesterday about SAI causing the steering wheel to return to center, and we have a similar effect with caster. Caster, as we rotate the wheel, and again, this should be more of an arc around there, but 2D. If we turn the wheel to the left in this case, the tip of the spindle is going to rise up, which would lower that side of the car. Or if we turn the vehicle to the right, the spindle is going to go backwards and lower the tip of the spindle, which is going to raise the body of the car. Caster, again, was used for returnability, and it's also one of the angles that can create a pull in our steering, because if these two lines don't match on both sides, one's going to have more load than the other, and that's going to create a caster pull. When we measure caster, we're really measuring, I'm going to go back to this picture for a minute. When we measure caster using our alignment equipment, what we're actually doing is measuring camber change as we sweep the steering axis. So when you do your caster sweep, you typically are going to turn left X amount of degrees, turn right X amount of degrees, and bring it back to center. And the machine is going to take how much camber change and calculate a caster angle. That measurement is a result of the 2 points that we're pivoting around. So it'll be the lower ball joint, and in this case, the upper strut mount. So we're going to be pivoting around that axis, and that's all that it can measure. It's not actually measuring anything about the true position of this. So when we go to this next picture, where we've got a frame angle, so now we've got a frame angle that's down in the rear. And again, this is something you can simulate on the trainer with the adjustments we have. But the strut has not changed position. Even though we physically have tilted the strut more, if you measure the caster, it's going to measure exactly the same. Because again, you're just measuring camber through the sweep. Same situation here. If we have a frame that's up in the rear or sagged front suspension, you can see that our strut is almost straight up and down. And yet when you measure caster, it would be the exact same as the other two pictures, because again, it's just the relationship of the strut to the vehicle, not the actual true vertical. So there are many manufacturers, and especially in pickup trucks, where they'll actually ask you to measure the frame angle. So, we compensate for these tilts and actually are going to measure the frame angle. And a lot of aligners now actually have a spot where you enter that into the specs. So you get a gauge and actually a magnetic degree indicator and stick it to the frame or to a level part of the vehicle and actually measure the angle and put that into your specifications. And if we get that angle, then that number is going to affect our camber setting. So if we had a frame that was tilted like this, so no load in it, it's obviously going to be tilted up in the rear. And in order to get some true positive caster in this, we're actually going to have to go to the high end of the specification. If we took a reading and didn't compensate for frame angle, this thing could say that it's perfect. But yet, if you look at the picture, we don't have any caster at all. Same in this case here. If we've got down in the rear, we're going to end up with more caster than desired. So in the case of this, with a frame angle down in the rear, we'll actually subtract and maybe work towards the lower end of the caster. So there's compensations that need to be made as we're doing our alignment. In the past, I know when we used to do pickup trucks, they always used to base the caster measurement on ride height of the front. So they were, I guess, making the assumption that the rear was always the same, and then depending on what the ride height at the front was, you would adjust your caster settings. So it's been good that a lot now are getting more into the frame angle. And like I said, a lot of alignment machines now have a place to enter that frame angle. Again, as the strut does make this movement, we've got two things that actually cause the vehicle to move the spindle. So we've got SAI, so that curved line that we talked about yesterday is kind of the travel that SAI follows, and the straighter line is kind of the path that caster follows. And there were a lot of vehicles, especially as we got into strut suspensions, where they said if you had a high steering axis inclination, where you get in that 11 to 12 degrees of steering axis inclination, it actually negated the effects of caster, meaning that caster no longer had as much effect for the returning of the steering wheel, nor for the straight ahead, or even to have pulls. So you'll find a lot of the front wheel drive vehicles don't even have an adjustment for caster. It'll say right in the specs, there is no caster adjustment allotted. Now, again, if it's really out, there are other things that could be possibly wrong, like cradle shift, or maybe there's some damage to a strut tower or something like that. But it's another diagnostic. If they're not the same, figure out why they're not the same.
Dick or Rick, somebody asked, should you check the vehicle height first?
That's always a thing that you should do, is check vehicle ride height before you start any of this process. That was, again, with the students I had, that was number one thing when we went into that portion of our curriculum. We were in the shop working on cars. Number one thing that they did before anything else, tire pressure and ride height. Always check the vehicle height. And there's a variety of different methodologies too. How to check the ride height. It's not just, a lot of the aligners just use a measurement to the fender, but there's a lot of others where you're measuring position of components to the chassis, angle of those components, those types of things. There's measurements from ground to certain points on the body. So yes, ride height is very important. Something I ran into not that long ago and was not aware of, we always think of caster as a front wheel angle. Recently ran into cars that now have rear caster settings. So Corvette was the one that was helping my son doing some diagnosis, and we got digging into it. And this is actually a picture of the rear suspension, I believe, on a Corvette. And there's actually a Kent Moore tool that plugs into 2 holes into the steering knuckle. And then there's a electronic level. And what you do is you place the electronic level on your alignment rack and zero it out. And then you go and attach it to that fixture you put into the suspension and measure the rear caster. Obviously, the rear wheels don't steer, so we can't do a caster sweep, but rear caster was very important, and found a lot of issues as we were doing the experimenting with this. Rear caster had a big effect on suspension loading when they would start putting lots of power to these cars. How I got involved is he worked in a shop that did a lot of modifications. So they were supercharging, turbocharging, all these things to these Corvettes. And they'd get into a lot of squat, and then the cars would start going all over the place because a lot of it led to the rear caster problem, and then it would also affect camber and toe. So something that, never talk in absolutes. You used to say, yeah, you'll never adjust caster on the rear, and there it is. And then in doing my research, I actually found out one of the first GM vehicles to have this was the Pontiac Solstice. Used the same tool, as a matter of fact.
And Mr. Voth also says the Dodge Viper, and as you said, the Solstice.
Yeah.
Rear caster.
Yeah.
Somebody else wanted to know what year vet was that?
I believe that was a C6 that we were working on at that time. And again, just the specifications now, as you can see, if you look under caster, we've got indication of front and rear, depending on the model of it, which engine and suspension package that it came with. So we're going to go into next talking about toe and toe out on turns. So again, just a simple diagram. We've got a simulation of tires, steering arms, rack and pinion steering gear, and tie rod ends. And as we move down the road, we often refer to the angle of the steering arm as the Ackermann angle, or the Ackermann principle is going to be applied to the steering arms. One of the older pictures I saw years ago was that it always showed the angle of the front steering arms. If we projected a line off of those, they usually met in the center of the rear axle. And that was quite often how a lot of the calculations were done. Now, I know there are some vehicles where the steering arms would be mounted, more onto the front side of things, where they would be up in here. But if you watch, the angle will actually come in here. And what this dot represents is the steering axis that it's going to pivot around. So in some of these animations, as they tried to, or not animations, but pictures, it kind of moves that a little bit. So, but I think we'll get the idea out of this. So we can adjust toe in by lengthening the tie rod ends. So if we lengthen the tie rod ends, we're going to make an adjustment typically here or over here, and we're going to adjust toe in or adjust toe, because it could be toe in or toe out. Not too many actually do you set with toe out. It's usually somewhere in the 0 to toe in range. As we drive this four-wheeled vehicle around a corner, though, all of these wheels and tires travel in a different arc. And this is, again, standard things that we always teach when we're talking about alignment. But all of these have to go in different circles. So the reason that we build those arms at an angle is that the math of it and the geometry actually causes a slight toe out on turns to reduce the amount of slip. So by moving this, and really what happens here is the position here, as this one moved, it moves in a little bit less linear fashion, is actually going to cause this wheel to turn a little tighter, whereas the one on the other side is going to travel a little bit more this direction and have a little less effect on the amount that the wheel turns. The inside wheel has to turn in a tighter arc. So it's the shape of those arms and the geometry of it that actually causes this. And the same when we go in the opposite direction. So again, the inside wheel must turn further. Now, things that can affect this. Oops. Sorry, I meant to go back to here. Things that can affect this are, that these have to be the same length, your tie rods. So your two tie rods have to be the same length when you're going straight ahead. That will make sure that, any other angles that are introduced as we work on this, because as you steer this, there's going to be an angle created there and an angle created here. So having different length tie rod ends, like severely different tie rod lengths, is actually going to cause this measurement to not be right. Other things that can affect this is the mounting of the rack and pinion. If the rack and pinion is not secured to the vehicle, or if we got bad mounts or things like that where it can move around, then again, those are things that are going to affect the angle, can actually affect the toe out on turns.
Rick, there are two questions for you in the chat.
Yes.
First one, what effects does positive rear caster have compared to negative in acceleration braking?
In acceleration and braking, well, in acceleration was the squat, and the rear caster, I believe, on the Corvette, I don't remember the spec, but I think it was around 4 degrees or something like that. But if it was uneven, it actually caused an uneven camber change, because the wheels do tend to toe a little bit under that much power. So it could actually cause a thrust problem. And same again with braking.
And second question, adding to that, would positive caster on the rear give better stability at high speed, as does the front?
Yes, again, because you're going to be following the load. So it's going to have, a little bit better tendencies to want to go straight ahead.
Very good, thanks.
Mm-hmm. So again, with the the Ackermann angle or toe out on turns, lots of things can affect this. There have been, again, playing around with things where people take an old car, like the one I showed you yesterday, and try and put rack and pinion steering on it. So they'll mount a rack off something else and connect it to the stock steering arms, and end up with all kinds of problems because you've changed so much of the steering geometry that, it changes the turning radius of the car. You got to change steering arms. So it's not just a matter of doing those swaps. And again, it can be a diagnostic thing. So a typical toe out on turns measurement is, again, there's a specification where you turn the turn plates X amount, measure the degrees on one side and the other, and look for the difference. One of the other things that we won't get into just because of time with tie rod ends is discussing bump steer. And as we first led to yesterday, that with tie rod ends or anything, like the tie rod's going to move in an arc, the lower control arm's going to move in an arc. So as these move up and down in our suspension, so as this tie rod moves up and down, the control arm moves up and down. they're going to travel in arcs, and the arcs of them will be different based on the two different lengths of them. But what we really want is to have the arc that they travel the exact same on both sides. The other things that guys are getting into is correcting the amount of overall bump steer by, again, positioning of the tie rod ends and where they're at for height so that the arcs get closer matched. One of the applications of this that go back again into older GM cars where they had the center takeoff racks where they had really long tie rod ends. And one of the primary reasons for those long tie rod ends is because it was so long it had less linear movement as it traveled through its arc, so it reduced the amount of bump steer on those, or the toe change through suspension cycle, because it's unequal toe change that actually gives us the bump steer. A couple interesting things about this tie rod end, and again, this is on our trainer, you can actually see an arc to it. And that arc is so that the tie rod can actually reach inside the wheel and get to the steering knuckle. And the arc clears the wheel and tire on this because of the offset of the wheel, which again was calculated when they did the scrub radius of this. So they determined where the wheel had to be mounted, and then we have to accommodate for this. So you can even get into problems if you put one of these on the wrong side of the vehicle or something where you could actually have the wheel contact the arc of this. So just some interesting things that you could run into. Last thing is, we mentioned this yesterday right off the bat, was talking about thrust and how much thrust is becoming an issue. That, you know, we want the vehicle to go straight down the road where the cameras are looking. Thrust is essentially skewing of the rear axle that's causing the vehicle to want to go one direction or the other. Typically, again, corrected by rear toe adjustment. Could be problems with suspension depending on the suspension type. If it's a leaf spring, you know, in a solid axle, you could have a sag spring, which naturally causes the axle to move back on one side and cause a thrust line. So there's lots of things that needed to be corrected there. One other thing in some of my recent research dealing with too is they're talking about tire slip angle, and you know, Ackermann has a lot to do with slip and tire slip, and now they're actually looking at that too, is calculating slip with a module to determine how much slip is actually happening in corners. So that's another input to the computer for the autonomous driving things. So there's things on vehicles now that can actually calculate the slip angle. So again, a lot of these things that we've talked about over the last 2 days can be accomplished using this trainer with all the adjustments we put into it. Obviously, it doesn't come with transparent tires, but you can still go through a lot of these same lessons using this. So that'll kind of bring us to the end of today. If there's any quick questions or anything that comes up, tomorrow my intent is to kind of wrap this all up and maybe go a little bit through the how I did all this. You know, what am I using so that I can do this, jump out in front of it like this.
Jim,
Rick, we have a question.
Asked if you heard
from
any ADAS issues with thrust.
Yeah, there were guys talking about that yesterday, where there were ADAS issues being caused by thrust. I don't remember the numbers. Dick was talking about it, but it was, you know, if the thrust is off by, what was it, Dick? Can you remember?
1 degree.
1 degree. It was same as what, 6 feet further out?
Yeah, at 135 feet ahead of the vehicle, 1 degree of thrust angle out of pure center would be a 5 foot or 60 inch to the left or to the right air in what the camera sees.
Okay.
We have a instructor who wanted to know what the little wheels are on the trainer. What do they?
Oh, these little wheels right here.
Yes.
Those will allow you to adjust the frame angle. So there's two on one end and one on the other end. The wheels and tires here, because the springs are only plastic, they don't actually support the weight of the unit. So these are mounted on bearings on both ends, and you can change the ride height of this whole frame, or you can actually tilt it forward or backward as well.
And create the same symptoms as a worn strut or worn strut spring.
Yes. Yeah. Or like we're talking about the frame angle too for your caster and things like that. You know, so you can do exactly what I said. You can measure your caster with it, create a frame angle and remeasure the caster and see that it really hasn't changed at all.
Somebody said manufacturers are recommending you adjust ADAS systems after alignments. Is that correct?
I would see that as being something you must do. And another big thing that's happening now too is you got steering angle sensors that are all inputs to these devices as well. So once you've done your wheel alignment, some cars have a process where you have to recenter or recalibrate your steering angle sensor as well. So that's another piece. There are some aligners now that plug right into the DLC, so you can do that. It's part of the alignment process.
I'm going to stop
Also-
the recording.
Also,